Hello, this is Mr. Precella, and today we're going to be discussing circles. And I'm assuming all of y'all have a general idea of what a circle is. It's a set of all points that are equidistant from some fixed point. That fixed point we call the center, and I'm abbreviating it. It's an ordered pair, x, y. I'm going to call it HK instead of XY. I guess we could have done X1, Y1 the way we do with lines. We'll use H and K. And the distance from that center to the outer edge is called the radius. And I'm going to abbreviate that with the R. Here's some more circle terminology that you won't be using today. But does anyone remember what the distance straight across is called?
Diameter.
The diameter. The diameter is twice the radius. That's just something extra. I'm not actually going to be doing anything with that. Now, in math or algebra, we always want equations. Equations have equal signs. So, if you want to write the equation for a circle, you're going to just be plugging in. It's x minus h squared plus y minus k squared equals the radius squared. That's called the center radius form of a circle. And it should be obvious why it's called the center radius form. To write the equation, you need the center and you need the radius. Now, here's a special case. If the center is located at 0, 0, can y'all imagine plugging a 0 in for h and a 0 for k? How would that simplify if you just put a 0 here and here?
It would be x squared plus y squared.
Yeah, just be an x squared. You don't need to write x minus 0. Plus y squared equals the radius squared. I think I've said enough for us to do problem number 1.
Are you sure?
I think so. Let's see. Oh, this has a very nice graphing tool in this section. I know y'all. I can see their excitement, Tim. I think y'all may like the multiple choice graphing problems better, but I like those graphing tools. So we have a nice graphing tool here. I'll do this one. Oh, okay. Okay, we want to find the center radius form of the equation of a circle centered at 0, 0. Let me write the pertinent information down. And a radius of 18. Okay. So we're using just the C to stand for center. Okay, let's switch it over. So we're going to write the equation. We have a center at 0, 0, and the radius is 18. So we know we have a center and radius, and we've already said if the x and y coordinates of the center are 0, 0, the equation will just have the form x squared plus y squared. Oh, this is an easy one. And what are we going to have on the right-hand side? 18 squared. That's right.
So
and
would it be technically 9 plus 9? Or 9 squared plus 9 squared?
It's 18 times 18. 18 times 18 is 324 for a final equation of x squared plus y squared equals 324. There's my center radius form for the equation of a circle. There's my center radius form. So let's go back and type that in. X. This little button right here lets us enter the exponent. Square. Is this the first time we've typed exponents? It might be. So is it? The little button have we or haven't we?
I mean, I think we might have done it before for like doing some of the things of like x squared plus x plus 0 thing, maybe.
Well, if this is the first time, then notice there's a hot button where it has a little bitty blue box there up in the exponent position, and if you hover over it, it says superscript. Now, I don't know why they don't just say exponent, but they call it a superscript. No, notice how it's spacing it nicely, even though I never hit a space key. But I'll hit right arrow
to get out of that exponent.
What was that? 324? Oh yeah, it's right there on the calculator. And I'll check my answer. Now I'll move that over there. And now we're going to graph it using this graphing tool. So let me show you how to use that graphing tool. There's a lot of times when there's a problem A and part A, part B, people think you've got to use the answer to part A to do part B. No. If you were going to graph this on paper, you would be or if you had graph paper, you would be using the center and the radius. If you had an old-fashioned compass, you'd put the sharp point at 0, 0, and then how far over would you move?
18.
18 and spin the circle around. That's what this graphing tool does here. We've got to say, which one do you think? It says to choose the tool. Which one do you think we're going to use?
The one that looks like a circle.
Yeah. Okay, so click the circle tool. It says plot the center of the circle. Well, that was 0, 0.
Yep.
Notice in the upper right-hand corner of the yellow rectangle, it says 0, 0. And then I'll click it. Now plot another point on the circle. Well, that means move over 18 units. You can move over 18 units left, right, up, or down, but notice it's showing the circle. So let me see. Have I moved over 18 units?
Yes.
It's going to the right, but it's also moving it up, down.
No.
So I'll click there, say save it, and then I can check my answer. Okay? Any questions there?
Nope.
The ones centered at the origin are easy to count the radius. But the ones that are not centered at the origin, it's a little more, you ought to be a little more careful when you're counting that radius drawing the graph.
Yes, I moved it to the right 18 units, and so I was at the point 18, 0. If I moved it up 18, it would have been showing 0, 18. Okay? It gets a little bit messier when the center is not 0, 0. See. So it's the same instructions as problem 1, except on this one the center is -1, 3, and the radius is 4. Okay. Now you're going to have to. Is it going to look like this one, the x squared plus y squared equals r squared, or are there going to be parentheses in this equation? There'll be parentheses. Now you have to be careful when that h and k are negative. Go ahead, Tim.
I'm going to denote the x coordinate of the center h, the y coordinate of the center k, and we know center radius form has an parentheses x minus, a parentheses y minus, and the radius being squared. What number am I going to write in here in the first set of parentheses after the x minus?
-1.
Okay, the h value is -1.
Because it's
We'll simplify that in a moment. Let's just fill in the spaces. Here,
3,
okay, the k value is 3.
4.
And the radius is 4, so 4 is being squared. Now, what were you saying about the x minus a -1?
Because it's minus and negative, it changes to plus.
Okay.
And it turns to a positive, so it's x plus 1.
And the y minus 3, we'll just leave it as y minus 3 quantity squared. What will we have on the right side?
16.
4 squared, I agree with 16. Before we go on, this problem makes a good point. Realize when you have an equation written in center radius form, the numbers you see inside the parentheses are exactly the opposite of the center. Here I see a +1 and a -3 in the parentheses, but the coordinates of the center are exactly the opposite. The x coordinate is a -1, the y-coordinate is a positive 3. Remember, center radius formula has those minuses already in the parentheses. As a result of those minuses, the signs you see inside the parentheses are exactly the opposite of the center. Any questions there? So we'll go type in that answer. X plus 1, oh wait, parentheses. X plus 1, close parentheses, hit the exponent key, square. And notice now you have to get out of that exponent before you type that plus. So do the little right arrow or click with your mouse, what have you. Plus, parentheses, y minus 3, close parentheses, exponent, square, right arrow. What was it? Equals 16? Yes. Mm-hmm. Any questions there? Notice how you don't use this answer to do part B. They could have had it the other way around. Part A, graph it, then part B, write the equation. These are two independent parts. I'll click the circle. It says plot the center. Oh, I forgot. What was that center? -1. Oh, -1, +3. Am I at -1, +3?
Yes.
Yeah. And now you gotta move over. What was that radius?
16.
No. The radius was 4. Don't use the 16 from the equation. The radius is 4, so yeah. Move up, down, left to right, 4. I'd go up. You go up? Okay, so I'll go up. 1, 2, 3, 4. Mm-hmm. You were at 3, you moved up 4, so notice now you're at 7 on the y-axis. See how I did that? And if I moved if I moved right, it would have still done it. Let's see, 1, 2, 3, 4 units. Same thing, 4 units down or 4 units left. I'll save it and check it. Are we ready to do another one like this? Any questions there? Okay. Number 3. Let me write it down. Same type of problem, except the center is 4, -3, and the radius is 6. Okay, just like in number 2, I'll label H and K. I already know R. I wrote it R equals for radius, so I know what the R value is. And I write my X minus, well, Y minus, and I'm going to fill in those 3 blanks. What's going to go after the X minus? 4, I agree. What's going to go after the Y minus? Okay, that -3. So watch. You have a Y minus -3. We'll simplify that in a moment. On the right-hand side, what's going to go in this blank? 6, I agree. So we have X minus 4 quantity squared plus, how are we going to rewrite that? Okay, that minus and negative becomes a plus, so we have a Y plus 3 quantity squared equals 36. Oh, let me move that up. Here's a better way to move it up. That, okay. Like I said a moment ago, The signs you see inside the parentheses, I guess I should say the numbers you see inside those parentheses, are exactly the opposite of the center. You see a -4 and a +3. What are the coordinates of the center? +4, -3. And that's important because in a little bit they're going to start giving you the equation, and you have to go back to the center and the radius. As I said before, in algebra, you always do it one way, then you do it in reverse. What we're going to be doing in a moment is, given this equation, you find the center and radius. So let's make sure we know what we're doing. If the equation's written in center radius form, you change sign. That gives you the center. What do you do to this number here to go back to the radius? You got to undo that square. So you take the square root. Look at number 2. Change sign. So the center is -1, +3. Yeah, that's it. -1, +3. You take the square root of 16, and sure enough, you get 4. Let me type that in, and then we'll graph it. Parentheses, x -4, close parentheses, hit the exponent key, square, right arrow, plus y +3, close parentheses, squared, right arrow, equals 36. Notice how it spaced it so nicely. I never hit a space key. As we go through this semester, never use capital letters, never use space keys. And let's see. Graph a circle. Oh, boy. The center was 4, -3. So help me out. Is that 4? Oh, wait. -3 would be down 3, wouldn't it? Am I at 4, -3? Look at the rectangular box. The coordinates say 4, -3. And now, what's the radius? 6. So we're going to move up, down. What do y'all want to do? Up, down, left, to right. What do y'all want Tony to move? Up, down, left, to right. It makes no difference to me. Right, 6. Okay, so starting at 4. 2, 3, 4, 5, 6. I remember one semester a student asked me, what happens if it's a fraction for the radius? It won't be. Okay, it'll always be a whole number. Let's see, so I started at 4, -3. If I move right 6, I'd be at 10, -3. So there, save it, and check it. Any questions there? I think they're sort of, number 4 is exactly the same. Let's do 5. This 5's a little different. What makes 5 different? Well, the center has a 0 in it. So center is 0, 1. That's the H and K. And the radius is 6. Okay, switch over. So we're writing the center radius form and drawing a graph. So I'll identify my H and K. And I think I'll write out the center radius form here, since it's a new page. I'll just write that out for us to remind us. So we have x minus y minus. Okay, what's going to go here beside the x minus? 0. The x coordinate of the center, I agree. Here. Okay, the y coordinate of the center, I agree with the 1. Here.
36.
Well, it's going to be a 6 squared, which will reduce to 36.
That's good.
X minus 0, we can simplify that.
X squared.
Okay, x minus 0 is just x, so we have x squared plus the y minus 1 will leave as y minus 1 squared. Any questions there?
Are you ready for me to type it in?
I guess so.
So x squared, right arrow, plus, parentheses, y minus 1 squared, right arrow, equals 36. I'll check that answer. And we'll graph it.
Once again, you don't use the equation to draw the graph. If you're going to graph a circle, you have to know two things. What are they? The center and the radius.
If you're going to draw a circle with an old-fashioned compass, you have to know where to put the sharp point and how far over to move to put the pencil. So I'll click circle.
I should go get my old compass.
I had, for years and years, I had a compass. We talked briefly at Baylor before we got hired here, and a teacher at Baylor gave me this big old compass you could use on an old-fashioned chalkboard. And a colleague used to come into my office when I was young.
Every afternoon.
And I'd be like, oh, wow, one day. And he was looking at my compass one day, and he said, oh, he'd love to have that for his kid. And I said, if you leave right now, you can have it.
No, you said, if you leave right now and don't come back, you can have it. He laughed and he took it, and the next day, guess what?
He came back, and I was like, wait. No. You took the compass. Don't come back. Oh. And he laughed, and I was like, I'm serious.
He never believed Tony was serious, but still.
But still, I don't have my compass. I couldn't use it anyway right now. It was made for a chalkboard.
That's being recorded.
Oh, wow. Shoot. Okay, so I'm going to move, I plotted the point 0, 1. Let's move up 6. 1, 2, 3, 4, 5, 6. So if I started at 0, 1 and moved up 6, should I be at 0, 7?
Yes.
Yeah. Okay. Any questions there?
You have to check your answer.
Oh, darn. Your confidence in me is just incredible, Tim. So in algebra, we always do it one way, then we do it in reverse, and maybe I'll let you see what the next problem's going to look like. See, here it says graph the circle. This is problem number 6. But in order to graph it, we've got to know that center and radius.
Well, I've told them how to find.
I know it. And so I'm going to change
sign and take the square root.
Yes, that's what I was going to go back to.
Remember, I said what you see inside the parentheses is exactly the opposite of the center. So change signs, take the square root.
Okay, on number 3, change the sign, square root. So on problem number 6, let me write it down. Though it's going to look like I'm not doing much of anything. I'm going to write it down and write out the answer. It says graph the circle. Sometimes students tell me, oh, I can do this without even writing anything down. And yeah, x minus 6 squared plus y plus 4 squared equals 16. The instructions say graph the circle. In order to graph it, you've got to know that center and radius. So here, change signs. Change the sign of the number in the parentheses with x. That's going to give me the center.
So instead of a -6, we have a +6. Change the sign of the number in the parentheses with y. What am I going to write for the y coordinate of the center? -4. To get the radius, take the square root. The square root of 16 is, is that all we need in order to graph it? I think so. You need the center, you need the radius. So the center is at 6, -4. So I'm going to pop that out. I'll click my circle graphing tool. The center is at 6, -4. 6, and I move down 4. Is that 6, -4? Yes. Yeah. And so, what do y'all want me to do? Do you want me to move up, down, left, or right? I'll do what y'all tell me to do. And they are so passionate about it, Tim. Just move right. Well, do y'all agree with moving right? Oh, okay. 1, 2, 3, and 4. We started at what? 6 plus 4? There it is, at 10, -4. Is that what we wanted? Realize, suppose the radius had been 5. Could we have moved 5 units to the right? No, in that event you would have had to move up or something, up or down, because... Well, either way it wouldn't have gone past. It wouldn't... There's one that could have a partial circle, not show the whole graph. Oh, there is. I don't recall seeing those happen. I may be thinking of ellipses. Okay, well, either way. And I check my answer. Any questions there? So if you have that equation with the parentheses, change the sign, square root. Okay? Number 7. Same instructions. Graph the circle. X plus 5 squared plus y plus 3 squared equals 25. So, in order to graph it, we have to know that center and radius. So, change the sign, square root. I'm going to write CS for change sign. Wait a minute. Sorry. So I'm just changing the signs here and here. This time the center, or both of these numbers going to be negative? Yeah, I think so. Changing the sign, it'd be a -5. Change this sign, a -3. Is that green ink showing? Yeah. And what's the radius going to be? Yep, 5. So change the sign, square root. So we come over here and click. Then click the circle.
What's the radius again?
Hold on. Is that the square root of 25, which was 5. So change the sign, square root. So, what's the center? -5, -3. So that's left 5, down 3. Is that it? Yeah. Yeah. Look at the yellow rectangle. Okay, and then we got to move 5 units. How do y'all want to move 5 units? Up, down, left, or right? It makes no difference to me. Up, okay. 1, 2, 3, 4, 5. We write -3 plus 5. That ended us off at +2. Hey, if we moved right the way my brother likes to, look where we would have wound up. Wouldn't we have wound up right here on the y-axis? Either way, it's the same graph. Save it. It transfers back over here. Any of y'all pop these graphs out here? Oh, it's the same thing, isn't it? Check answer. Any questions? So at this point, you know how to find the center and radius if it's written with the parentheses. But no one's asked or wondered about that x plus 5 squared. How, if you were going to multiply that out, you don't just square the x and square the 5. It's a 4-letter algebra word starting with F. How would I square x plus 5? You'd have to FOIL it out. So that's what you would do if you wanted to get rid of those parentheses. You'd have to FOIL out the x plus 5 squared and the y plus 3 squared. The natural question to ask is, what would we do? Let's go ahead and let them see number 8, but we're not really going to be ready to start number 8 yet. It's the number 8 says, find the center and radius and then draw the graph. How does that differ from number 7? Well, number 7 has the parentheses in it.
That's center radius form. It's easy to find the center and the radius when the equation's written in center radius form. Okay, change sign, take the square root. Suppose the equation is not in center radius form. Notice,
this is called expanded form when someone had FOILed it out. This is one of those times when doing extra work is not really a good thing, is it?
Yeah. They FOILed out the thing, the binomial square with the x. They FOILed out the y minus something. Looks like they combined all the constants on the right-hand side to get a single constant term.
So, flip it over here so I can show what I've written.
Wrong thing.
Our goal here, if we're going to find that center and radius, our goal should be to write it like this. If we can write it back in that center radius form, then we know how to find the center and radius. The center and radius. Yeah, change the sign, square root. Most basic problem-solving strategy. If you know how to do one problem, like 6 and 7, we know how to do that. When we're confronted with a new problem, try to make it look like the one you know how to do. So we need to somehow take all of this stuff and rewrite it with these parentheses. Well, let's review some factoring before we go back to number 8. Okay?
Perfect square trinomial. Back when we were solving quadratic equations, I said there was a fourth method that could be used to solve quadratic equations, and it involved completing the square. And I said completing the square worked best with circles, so we delayed introducing completing the square until now. Now you're going to see what I mean by completing the square.
Let's just... There, let me move this up. It's been a while since I've factored in here in class, or you either, right? But maybe you've been factoring on your homework, okay. But let's just review. If I were going to factor this, I would need to draw my 2 sets of parentheses.
Because the one on the opposite side, or the one that doesn't have an exponent, is positive. It's both of what the first one is. If
okay.
the first one's both negative, then it's x minus and x minus.
Okay. If the second sign is plus, we have 2 of the first. So it's going to be minus and minus.
X minus and x.
And then it's going to have to be x and x. Now, for 25, there's not a lot of numbers that multiply together to give 25. 1 and 25, 5 and 5. Y'all have a feeling of which one's going to work?
5 and 5.
5 and 5?
Because negative 5 plus negative 5 is negative 10.
Yes. This is called a perfect square trinomial. If you have the same thing in both sets of parentheses, then it can be written like this. X minus 5 squared. So, some observations on perfect square trinomials. The only way you're going to get the same thing in both sets of parentheses is if this second sign is plus. Do y'all remember when factoring, if the second sign had been minus, you would have to use 1 plus, 1 minus. Also, this last number has to be a perfect square. instead of 24, if it had been 20, there's no way you would get the exact same thing in both sets of parentheses. Also, when we look at the equations of circles, there's not a number in front of this x squared. I guess theoretically there's a 1, but we don't normally write it. So with these perfect square trinomials, it should start off with just x squared. It should end with a plus perfect square. Let's try factoring this one. Y squared. How about a plus 20 y plus 100? Y'all figure out how to factor this? Is it a perfect square?
Yes.
Well, let's see, we would put y times y.
And they're both positive because the second one's positive.
Second sign's plus, so 2 of the first. That second sign has to be plus. If it isn't, then you're not going to get the same thing on both sets. Both sets of parentheses.
What equals to 100 that can also equal to 20 is 10 and 10.
10 times 10 would equal 100. 10 plus 10 would give us the 20. So 10 times 10.
So it's equal to y plus 10 squared.
Realize with a perfect square trinomial, that constant term there, that number there, has to be a perfect square. You can't have 70 there. You have to, the number that's there has to be able to be written as a number times itself. So that constant term there has to be a perfect square. Hey, now let's try this. I'm wondering, could y'all give this some thought and figure out what number needs to be in this blank? If it's going to be a perfect square, I'll put x and x. Second sign is plus, so 2 of the first, so minus and minus. Now, what perfect square would need to go there? It would need 16. If I put a 16 right here, would that factor as a perfect square?
Yes, it would.
Yeah, 4 times 4 is 16. 4 plus 4 is 8. Oh, where's my purple pen? I was thinking we were missing something today. What about this? Y squared. Oh gosh.
Plus 6y.
Plus 6y. What perfect square would need to go right here?
9.
9? If I put a 9 there, would it factor as a perfect square?
Yes.
It would be y and y. What about the signs?
Both of them were plus. And if it's 3 and 3, that would make sense because 3 plus 3 is 6 and 3 times 3 is 9.
Did y'all hear that? Perfectly said. 3 times 3 would give us 9. 3 plus 3, 6. So let me go ahead. Oh, okay. But how, if you're having trouble, how are you figuring out this number?
Look for a pattern. The 8 became 16, so don't think it's times 2. The 20, we had 100. What
10,
do we do?
If you were going to write out, what do I do to this number to get that one?
There are 2 things.
I'm going to say take half and then square it. Did you want me to have them figure that out, Tim? Oh gosh. There was some TV show where the person was talking to a bad teacher. And he said, oh, so a teacher is someone that just does everything for you and you never do anything on your own. And I was like, oh, wow. Oh, gosh. Are they talking about me? No, but y'all do plenty on your own. Okay?
I actually have one teacher who pretty much just kind of gave us the answer to every question that we ever had.
Oh. Well,
it was not good because I had to have a lot, because it comes like test time and stuff. I would need to ask my friend for a lot of help. I had to ask my friend who was a fluent Spanish speaker for a lot of help on it because he knew a lot about it and I knew nothing because the people didn't really teach anything.
Oh, well, okay, what number are we going to add into that blank? I'll tell you this much.
144.
You have to you start with this number here, you take half of it. Half of 24 is?
12.
And then 12 times 12 is?
144.
Okay, well, so, I agree with your 144. Now, how is that going to factor as a perfect square? We're going to skip this. We're going to skip these steps here.
Minus 12.
I'm just going to go straight to this one. It would be x
12.
plus or minus, minus, and then the square root of 144 is 12. So you may have forgotten, what the heck are we doing this for? We want to be able to rewrite this so that we have parentheses, so we can do the change the sign, square root. Okay? So do we have a way of doing it? Actually, yeah. We're going to have to put our x's together, draw a line, and put a perfect square in it. Put our y terms together and draw a line and put our put a number in that line and factor it. Let's just get started. Let me write down number 8. X squared plus y squared minus 10x plus 2y equals 38. Now we're going to be adding numbers to the left side with x, and we're going to have to add a number to the left side with y. But this is an equation. So when you add something to the left side, it's like a big old, one of those big scales. If you add something to the left side to maintain the balance, you'll have to add it to the right side also. So get ready. Let me switch over. I gave a little leaflet way back in the day before videos. We had leaflets.
Did everyone get one of these
handouts? There's some
handouts?
people that didn't get one of those. Walk around and pass it out. That handout just sort of summarizes everything we said back in the day before the videos. Every class had some leaflets where I was trying to summarize for people that weren't here or whatever. But to get going, you start off, write the equation, grouping the x's together, and then put a plus blank. That line is the same as these lines right here. So I put x squared minus 10x plus blank. Then I'm doing the y squared. Y squared plus 2y plus blank equals 38. And something my brother said a moment ago, if I'm adding a blue number on one side of the equation, I better add it to the other. So I'm going to put a plus blue blank. The same thing with the plus red blank. Now, how do we fill in these blanks so that we get one of these perfect square trinomials?
Take half of the first one, then multiply it by itself. So it'll be plus 25.
Okay, so you take half of 10. Let's say, I'll just say 10 over 2 is 5. 5 squared is 25. And what I'm doing here is just trying to show my thoughts. That's how I'm getting this number 25 right here. And I better put it over here on the right side also to keep it equal.
And then for the second one, it would be 1 because half of 2 is 1.
Okay, so I'm going to write it out in words here. Take half. Half of 2 is 1. Square it. 1 squared is just 1. Okay. Now, what we just did was something called completing the square.
And remember how you go from the trinomial to the binomial square. That's what you need. Center radius form has that binomial square. Okay, so with that in mind,
I'm now going in blue, the x squared minus 10x plus 25. How would that factor? It would be, I'll get us started, x, then plus or minus. Minus, because of this symbol right here, 5. The square root of 25 is 5. Is it starting to look better? Have y'all forgotten what the heck we're doing? We're trying to get it written so we can do the change the sign, square root. Now what about the y? What's that going to be? It'd be a y.
Plus 1.
Okay, so I'm going to make it look worse with a lot of little arrows. I'll write down this variable. This is the sign, the very next sign. So plus, and then the square root of the last number, the third number there, the one in the blank. The square root of 1 is just 1. Actually, maybe here would be a better thing for me to draw my arrows. X, take the next sign, square root, equals, what number do we have on the right?
64.
38 plus 25 is 63, plus 1 more is 64. Is it now in the form that we can do change the sign, square root?
Yes.
Okay, that was the goal. Is it clear what our goal was? The goal was to try to make it look like these two problems here. If it's written in that center radius form with the parentheses, change the sign, square root. So what's the center going to be here?
5, negative 1.
5, negative 1. Change the sign of the number in the parentheses with x. Change the sign of the number in the parentheses with y. And what's the radius going to be? The square root of 64 is 8. Now after all of that, I think I've almost forgotten what the question was. Were we going to graph it or what?
Any questions before we graph it? We'll do more of these, okay? You'll get the hang of it. It just takes just got to do a few. So we click. It's a circle, and the center was 5, negative 1. Oh, no. That's 6. Oh, look at that. They're incrementing in units of 2, aren't they?
Oh, my gosh.
Yeah, they're so remember to look at the coordinates up there in the yellow box. Is that the center that I want, 5, negative 1?
Yes, it is.
Okay. And what's the radius?
8.
I think I'll just move to the right then. Okay.
5 plus 8 would be 13.
Oh. Is that it?
Yes.
Be careful when you're moving whatever that radius is. Notice the way they're using, sometimes they'll just use half increments, okay? Or increments of 2, so the 1s and the 3s are right there in the middle. And any questions?
What was the number, and looking back at all of this,
looking back at it, a center radius form, what has to be the coefficient for the x squared and the y squared? If you started foiling that out, would you have a 3x squared or a 7x squared? What would you have to have as the coefficient if you foiled this stuff out? It should be obvious.
I'm guessing you're saying that now because the next question's going to have
It's going to have something.
Show this. Looking at these, every one of these, it's just a 1 in front, just an x squared or a y squared, okay? If we actually came over here and started foiling these out, it'd start off with x squared, and here it'd be y squared. There shouldn't be a number in front of the x squared and y squared. And if we look at number 10, Problem number 10 is going to have an extra step. Let me write it down. Hey, but look at that. It's multiple choice, huh? That looks like something from about 15 years ago. 3x squared plus 3y squared. Oh, good, Tim. Hide those answers.
Wait, this kind of looks slightly easy because since they're all divisible by 3, we could just divide them all by 3.
Exactly. That's what I wanted you to say. Did y'all hear that? There shouldn't be a number in front of the x squared and y squared other than a 1. If there is, then you're going to have to divide straight through. Here, on problem 10, hold on, we're going to make it look like problem 8. In problem 8, there wasn't a number in front of the x squared. So I'll divide through by 3. And it works out really nice. Once you realize you got to get rid of that number in front of the x squared and y squared.
X squared plus y squared plus 8x minus 4x.
4y.
4y, sorry. Plus,
is it 16? 48 divided by 3?
Equals 0. And because it's equals 0, don't you have to minus 16 on both sides?
Yep. We're going to start off now grouping all the x's together. I'll write all the x terms in red and put a red blank. It'd be x squared plus 8x and plus blank. Then I'll use blue for the y terms. I'd say plus y squared minus 4y plus blank, and move that 16 over.
Equals negative 16.
But you know what? While I'm thinking about it, let me put a plus red blank and a plus blue blank. Anything you add to one side of the equation, you've got to add to the other. So what's that red number going to be?
It will be 16 because half of 8 is 4, and squaring 4 equals 16.
Okay, so half of 8 is 4. 4 squared, 16. So I'm adding a 16 to both sides.
And because it's negative 16 plus 16, we can just cancel that out.
Yeah,
So
the negative 16 plus 16 is 0, so they're gone.
So that will make the equation actually even more easier. And that would actually be 4 as well, because half of negative 4 is negative 2. Negative 2 times negative 2 positive 4.
You see, I always just think of the number part here. You're saying half a negative 4,
which is more formally correct.
Which is more formally correct. But to me, when you square it, it's going to be positive anyway. So I just look at the number part. That minus sign there is important because that's what's going to be in the parentheses when you factor it in a moment.
Half of 4 is 2. 2 squared is 4. Is it clear for where we're getting these numbers in the blank? Do I need to, like right here, you take half of 8 and then square it. That's where that 16 is coming from. And now can we factor it so we have the parentheses?
Yes,
Look what you can do.
Okay.
So I'm going to factor the red terms. Tony, do you write those little braces?
Oh, no.
Oh, goodness. I saw a moment ago that you weren't writing it. I just wanted to yell, don't forget your braces. Okay, the little red terms there, they're going to become variable. What sign will I have?
Plus.
It's variable, sign, I agree.
And it will be 4.
Okay, the square root of 16 is 4.
Then it's plus y minus 2.
So
Or would it be y
variable.
Plus 2 because it's
The very next sign.
Okay, variable, sign, square root of the number.
Okay, so
Although, I'll tell you what I do. I go variable, sign, half of that number. The first two things written there, that's what I look at, okay, when I'm factoring. Variable,
the first sign, half of 8 is 4. Variable y, the first sign minus half of 4 is 2. It's the same thing as taking the square root of that number you added. So either one of them will get you to the correct answer. And what have I got on the right-hand side? Not a trick question.
4.
That's right. The negative 16 plus 16 goes to 0, leaving you a 4. Is it in the form that we need it to go change the sign, square root? Mm-hmm. I must confess, my little braces, I used to make those things perfectly. And I guess after 2.5 years of not doing it, look at that. Yeah. Looks like my 95-year-old mama drew those little braces. Yeah. I know, but still, I'll have to practice that. What's the center? We can look now and tell the center.
-4, +2.
Okay, the center. Change sign, so I agree, -4, +2. The radius, we take the square root of the last number. So the green 4, so the radius is 2. Okay. Any questions there? You know, I think my braces make it look even messier. I used to think, wow. Huh. Okay, so, I forgot, we don't have to use that graphing tool. Oh my gosh, which one is it? A, B, C, or D? It is A, -4, +2, radius 2. Yeah, okay, A. We're not even graphing it, we're just finding the center and radius. Okay. Now, back in the olden days, before there were videos where you could re-watch and listen to everything we say, this was what we had in classes. And right up here, I'm just sort of summarizing what we've said already about, center 0, 0, center HK, and so forth. And right here, down here in this lower, 2/3 of the page, that's a recipe summarizing what we're doing. Hopefully you don't have to, just follow this, word by word. If A is at 1, divide by A. That was like on problem number 10. That first number was not 1, so we had to divide.
You might have frozen the screen because it has in the corner.
I know, but that's just the zooming.
No, that's just the zooming. That's just the zooming. It's showing what part of the page I'm zooming on. Okay?
And so then you rewrite it, but I have all the steps right up here summarizing what we're doing. But a word of warning. There's some special cases. Special cases. Oh, wow, this purple pen is no good. I'll use this one. Suppose right out here at this last step, if we had gotten a 0 over here, could you have a circle with radius 0? If you had a circle with radius 0, it really wouldn't be a circle. What would it be?
A dot.
Yeah, just a dot. I'll say point. Okay?
In particular, it would be the center point. If you had the equation center radius form, the parentheses on the left and a 0 on the right, all you have is that center point.
Are you telling this because that might be a question?
Yes.
It may happen in the homework.
Now, let's suppose, do y'all remember something about square roots of negative numbers? The square root of a negative number is what type of number?
The square root I. Imaginary.
Yeah, an imaginary number. If, here on the last step, if you wind up with, let's suppose this has been a -4 and you have a radius of 2i, then that means there's no graph, not even a point. Okay? No graph at all.
If you think about it, here, when you write an equation in center radius form, you plug in something, you square it. No matter whether that's positive or negative, when you square it, what sort of a result are you going to get? Starts with a P.
positive.
Okay, positive plus positive. Can a positive plus positive ever equal a negative? No, so you can't have a negative number over there on the right side, or else there's no graph at all, not even a center point.
Right here at the very bottom of this little leaflet, you want to zoom in so they can see it? Well, I guess you have your own sheet of paper, don't you? Okay, well, I'm just writing what I'd said earlier. If R is 0, the graph is not a circle, it's just a point. If R is imaginary, then no graph, not even a point, exists. There's one other special case I should mention. Suppose there hadn't been any x squares or y squares. What kind of figure do you have if there's no exponents at all? Starts with an L, a line, okay? So if there's no exponents, then it's a line. Let's do problem number 12, Tim. Let's do the even numbers. Number 12 says, decide whether or not this equation has a circle as its graph. I don't really like those instructions because it makes it sound to me I should be able to look and tell, is it a circle or not? But really the only way you can tell if it's a circle versus a point versus no graph at all is by actually finding that radius. If the radius is 0, then it's a point. If the radius is an imaginary number, it's no graph at all. There is one thing we can do right now, looking at the graphs. The answers, A, B, C, D. I claim it, the answer cannot be A. Look at part A. The graph of the equation is a line. Could it be a line? No, there's squares, okay? So that's all you can tell just by looking at the equation. You can say, well, the answer is not A. It's definitely not a line. So let me write down number 12. X squared. Hey, we're not going to have to do any of that dividing like you do on number 10. Plus 4x minus 8y plus 29 equals 0. Okay. Okay, let's switch it over. You're going to have to assume it's a circle and start trying to find the center and the radius. In order to do that, you've got to all group. I'm going to move this up and you lift that up. And let me move my calculator out of the way. I'm going to group the x terms together. X squared plus 4x plus, skip some space, and then I'm going to group my y terms together. Y squared minus 8y plus, skip some space. What am I going to do with this 29? I'm going to subtract it. I'm going to get it over here on the right hand side, so that'll become a negative 29. And realize I'm going to have to add this purple number and the black number. There. So what's the purple number going to be?
It's 4 because the half of 4 is 2. 2 times 2 is 4.
Okay, so you took half of 4. Half of 4 was 2. And then 2 times 2 was 4. So you add the 4 in the purple blank there. But if you add 4 pounds to the scale, you have to add, on one side, you have to add the 4 pounds to the other side to maintain the balance. That looks like a funny 4, doesn't it? That's a 4 there.
And then for the other one, half of negative 8 is negative 4. Negative 4 squared equals 16.
Okay, so you took half of the 8 to give you 4. And then 4 squared is 16. So I'll add 16 to both
And we
sides.
can tell right now that it will be a negative number because 4 plus 16 is 20, so it'll just be negative 9, so we know that it can't work.
Yeah, but let's go ahead, just for good practice.
Just to
Let's,
practice factoring, but what you said is exactly right. At this point, you could stop right now. But just to practice that parentheses square, it would be
X, and then what? Plus or minus? Plus
that very next sign.
number, not 4, 2. Okay. Variable, sign, half of that number, or else square root of that number. It's the same thing. Here, y, sign, okay,
Minus.
variable, sign, here, no. And over here, you're right, negative 29 plus 20 gives us a negative 9.
So you really didn't need to do these parentheses. Why? Well, if this is going to give you the radius, the square root of negative 9 is not negative 3, it is
3i, there is no graph.
not even a dot, no graph at all. Okay, if the radius turns out to be an imaginary number, there's no graph at all. And the way it's worded on here, I think it says non-existent. The graph is non-existent. Okay? If the radius had turned out to be 0, then your answer would be B, a point. Any questions there? Let's do one more of these, number 13. Let's see. Same instructions. All we know for a fact just by looking at it is the answer is not A. How do I know it's not a line? Well, the squares. Right? If there are exponents in the equation, it's not a line. Okay? Okay.
Oh, it would equal to 0.
Make sure I didn't miscopy that.
Oh,
Make
let
sure
me see.
that it was a plus 13.
Minus square plus.
Yeah, okay. We're going to group the x terms together. X squared minus 4x plus blank. And now we'll group the y terms together. Y squared minus 6y plus blank.
Equals to negative 13.
Okay, move the 13 over so you have a negative 13.
Don't forget to put the plus on that side because what you do to the left, you do to the right.
That's correct.
The first one we've done so many times that we know already that it will be 4.
Half of 4 is 2. 2 squared is 4. I agree. We're going to put a 4 in the blue blank there and there.
And the other one would be 9 because half of 6 is 3. 3 times 3, 9.
Okay, did y'all follow that? Half of 6 is 3. 3 squared is 9. So we put a 9 there and a 9 there.
And if we add it all together, then it would be 0. So it will be a point.
You see?
Okay.
So here you don't need to go through doing the factoring. Once you see, oh, that number on the right-hand side is a 0, the radius would be 0.
Let's go ahead and factor the thing. So
Yeah,
just
because
for
then
good
you'll find
practice.
exactly what point it is. Just to practice doing this
It will be
factoring.
x minus 2.
Okay. Variable, sign, half of that number.
And the other one would be x minus 3.
Not x. Y minus 3. Variable, sign, half of that number.
And then it would be the opposite sign, so it would be 2 comma 3.
In fact, that is the point.
The radius is
Not
0.
negative 3.
Oh, positive 3, Tim.
Oh, positive 3. Thank you. The graph is just the center point. that graph would have the center, but you wouldn't go up, down, left to right. The radius is 0. We punch that in. Oh, well, not punch it in. What do? I just click here.
It'll be
Okay. And once you hit number 14, it's review. Oh, cut point method and so forth. Any questions on this?
nope.
Well, then, remember I said if you have a Chromebook and you want to take the test here, during class with one of us proctoring it, just let me know. Or let me know. Let one of us know. Okay. And we're working on finding a lab where you could take it with the proctoring system here on campus, but at this point, the lab that we were told had the system doesn't. So, and they're not inclined to put it on there, so. Well, anyway. But if there's no questions, then we'll call it quit. We'll see you on Thursday. I'm going to stop the recording. If you have a question, you can answer it without, or you can ask it without being recorded.